Hypothesis testing, two proportions, and we're going to do it in the calculator. Okay, so a two proportion hypothesis test is very similar to the one proportion hypothesis test, which we did in an earlier video, except for now, as you can probably guess, we're going to deal with two populations instead of one. Per the usual, let's go over the conditions necessary. If you go back to the population proportion video, we talked about how n times p hat has to be bigger than 10. Just to remind you, p hat is your number of successes divided by your sample size. So please go back and look at that video. But anyways, because we're dealing with two different populations here, two different samples, what we need is both n1 times p1, so that's the number of that's the sample size of the first group times the sample proportion of the first group. We need that to be bigger than 10. We need n times they're calling it q1 here, but just keep in mind that q1 hat is just 1 minus p hat. Anyways, we need n times p to be bigger than 10 and all the n times q's to be bigger than 10. Okay, if those are satisfied, then we can perform something that's called a two-prop z-test. Okay, so if these conditions are met, we can perform a two-prop z-test. How do you get to it? Well, a two-prop z-test is located where all the hypothesis tests are. You hit your stat button, go over to test, and then you scroll down to two-prop z-test, which should be number 6 for most of us. All right, example. Suppose you were asked to determine if the population proportions of men who play intramural basketball at two different colleges is different. If 145 out of the 900 randomly selected students at college A play intramural basketball, and 235 of the 1,095 randomly selected students at college B play intramural basketball, perform a hypothesis test to determine whether the true proportions of the two colleges are statistically different. We're going to use an alpha of 0.10. Okay, so we're testing here two proportions. So similar to what we did for the two means is that we're going to have, instead of having p compared to a number, we're going to have p1 compared to p2. We're going to compare the proportion at college A to the proportion at college B. Subscript 1 is A, subscript 2, B. So we are trying to determine if the proportion at college A is different than the proportion at college B. Different means not equals to. That is our claim, which is the alternative hypothesis. The null hypothesis is P1 equals P2. Always start with your hypotheses. All right, so matter of fact, let me pop over to a two-prop z-test and let's talk about what type of values we need. So test, the number 6 of the two-prop z-test. Not a whole lot. So what we need is an x1 and n1, x2 and n2. So let's discuss those. x1 will be the number of it's the number of men who actually play intramural basketball at college A. X1 for us will be 145. That's the number of men at college A that play intramural basketball. N1 will be your grand total of men that you surveyed at college A, which is 900. X2 will be 235 because that's the number of men who play basketball at college B. And N2 will be the sample size of college B, which is the 1,095. Okay. Keep in mind, just like it was for the previous one prop Z test, X and N must be whole numbers. And I forgot to mention in the previous proportion video, but hey, your x has to be less than or equal to n. And if you flip-flop that, you're going to have an error. If I flip-flop come over to 145 and 900, what this means right now is that out of 900 people, 145 of them play basketball. That's plausible. We can do that. But if you put your x1 as 900 and your n1 as 145, you're saying out of 145 people, 900 of them play basketball. That's impossible. Okay? So be careful with your x and n designations. All right, it's a two-tailed test. So we're going to put all this information into the calculator. All right, here we go. 2 prop z test. X1 was 145. N1 is 900. X2 is 235. And the N2 was a 1095. And it was a two-tailed test because we're testing to see if they're different. And we calculate. And a bunch of stuff pops up. The z-score is our test statistic if we're interested in that. But the p-value is the p without any hat on it. Okay. P1 hat is if you take x1 divided by n1. P2 hat is if you take x2 divided by n2. P hat is if you take all the successes together, the x1 plus x2, and put it over the grand total of n1 plus n2. Anyways, P is 0.002. All right, here we go. Let's compare that to our alpha of 10%. Two is less than 100. The p-value is less than alpha, which means that we should reject the null hypothesis, which indicates that the conclusion is there is enough evidence to support the claim. So yes, there is a difference in the proportion of men playing basketball at the two colleges. All right, one more. Suppose you're asked to decide if the residents of New York and Tallahassee attend the same number of movies. If 49% of 2,500 New York residents who were randomly selected said they attended movies, and 52% of the 850 Tallahassee residents who were randomly selected said that they attended movies, perform a hypothesis test to determine whether the true proportions of, oh, that's a typo, not the colleges, but if the two proportions are statistically different, meaning are the proportion of residents in New York attending movies at a different rate than the residents of Tallahassee. Okay. All right. So we're going to compare P1 to P2. So I'm going to let 1 represent New York. And we're going to let 2 represent Tallahassee. Okay. It really doesn't matter how you designate what, but we'll just go with that. So 1 for this in New York, 2 is Tallahassee. All right, we're trying to test if P1 is different than P2. So that means the HA is a not equals to. You guys know what's up with the null. It's an equals to, just like before. All right, let me come over here. Need an X1, need an N1. Also need a X2 and an N2. Okay, 1 is New York. So 49% of the 2,500 residents in New York said that they attended the movies. So that means that X1 is 49% of 2,500. AKA, that means that we have to take remember, convert percents to decimals. We have to take a 0.49, multiply it by 2,500. I have no idea what that is. Let's see, 0.49 times 2,500. 1225. So our X1 is 1225. So 1,225 out of the 2,500 New York residents attended the movies, which means our N1 is 2,500. X2 is found in a similar fashion. 52% of the 850 Tallahassee residents went to the movies. So that means the X2, the number, right? The number of Tallahassee residents that went to the movies is 0.52 times 850, which is 442. Okay. As before with proportions, remember X has to be a whole number. If you multiply this out and you're getting a decimal, make sure you round up to a whole number. N2 is 850. And now we have all the information we need in order to perform our two proportion hypothesis test. Here we go. Clear this out. Stat, test. Number 6 is what we're doing, 2 prop Z test. X1 is 1225, where the N1 was 2,500. X2, 442. And 850. The HA, what was the HA? It was a not equals to, it was a two-tailed test. We go to calculate, and we're in there with a p-value of 0.131. Okay. Alpha's 0.05, so let's do our same song and dance. You take your p-value, compare it to the alpha. 131 is bigger than 50. That means the p-value is bigger than the goldfish, which means fail to reject the null hypothesis. Which means, what's the conclusion? There is not enough evidence to support the claim. Okay, I appreciate y'all watching my videos. See you in the next one.